Okay, welcome to Glance stream number 2. Right now I'm going through the code, seeing if there's anything I want to refactor. If you're not aware of what Glance is a visual programming language for Haskell. The current code is a visualizer, so you give it Haskell code as input and it spits out a diagram. And what I'm working on now is a GUI for Glance. So you'll be able to directly edit visual Haskell code. And right now it's just a very basic sort of prototype. I can add nodes and I can move them around. I'm really just learning how to do GUI programming, learning how all the GTK and Cairo works, and still at the early stages. And if you have any questions, if you're new to Haskell, or if you have any questions about coding or anything, please ask. Okay, so I was looking at this get FPS. So get FPS is just directly done in update state. And is that the only thing that use inputs? No, it's also used there. So I think that's good for now. One change that I've made is I'm using this event stop constant. I believe this is true. Let's check that. Oh. And what this means is don't further propagate the GTK event. Okay, so I think the code's good for now. So I'm going to update the to-do and remove that to-do. Okay, so let's start on the second to-do, add history and undo. And so there's actually a GitHub bug for this I made. So that way people who are following the project on GitHub can see what's happening. Okay, so history and undo. So for this, what I want to do is I have this queue in events, in inputs, this list of input events. And I think I can think of two ways to do history. One is I can save all of the app states, basically snapshots. And so whenever the app state changes, I could save that over time, and then to undo, you just play back. You just take an app state from the past and say that's the current app state. So an issue with that is that this app state is changing. It's being updated about 800 times a second. So notice the FPS is 800. That's how many times the app state's being updated. And every time you move a node, the way that works is it's actually changing the app state. And so I think that would be fairly wasteful and would probably not work too well, since that would just be a whole lot of state that's not really needed. So my other idea is basically have a list of events, or let's say I'll have a list of updates. And these could be input events or things like that. I'll call it a history event. And as the state gets updated, these events get written to the list of histories. And in order to do undo, each history event has an undo action. And so you play back through the history of the events and you find their corresponding undo actions and execute those. So I'm not too familiar with GUIs or how other programs do that. So I think I'll try that, see how it works. If I have issues, then I'll probably look into that. Or if you're watching and you have suggestions, please let me know. Okay, so I think I'll just start with making the history events essentially a superset of the input events. So the input events are defined here. So let's make a history event. So the first input event is click on node, which isn't really what I want in the history. I don't really care what's being clicked on. For the history, I just care about where did you move the node and where did you move it from. So let's make this a move node event. And we also had an add move input event, and that makes sense to include. So this is history, so I'm just going to make these past tense in order to avoid conflicts with input event names. Okay, so now I'm going to add a list of history events to the app state. Okay, so we have our move node and our added node events. Okay, so now let's see. Okay, so now we have our history events. We have them in app state. We need to modify the default or the initial app state to have that. So that's just the empty list there. And now we need to actually make these. So I'm going to start by going to process event, process input. Okay, so let's start with add node. And so we're going to update AS elements, and we're going to also update the history. Okay, so this is just the identity. It's saying the history is the history, and we aren't going to change anything. And so now this is add node, so we're going to add added node to the front of the history. So let's make sure this still works. Okay, code still compiles and still works. Now it would be cool to, let's say, print out the history here. Let's see where I can do that. Let's make that in the background press event. LeftClick Action. Okay, so this is in the IO monad. So that means we can just directly print things. This is just for debugging. Okay, and so for history event, I need to give it a show instance. Okay, let's see what happens. Okay, so when I left click, now it says added node, added node, added node. And now we have more added nodes. So that is being added to the history. Great. Let me make a note. Okay. Okay, so now let's add the node for let's add the history for clicking on a node. So we're only going to register a move when we release a node. So that's going to occur if the as moving node is something, and then we click on the node and it becomes nothing. So this is the case where we want to update that. So the first thing I'm going to do is I'm going to extract out this function here. Okay, so we have the element ID, we need the old state, and we actually need to get out the moving node. Okay, so that is compiling now. Great, let's test that. Okay, so I can still click on nodes, that works. And I no longer need to get that. Okay, so this is returning the new history. So and we're going to do different things in different cases here. So I'm just going to sort of inline this here. This was element ID, I believe. Okay. So I just inlined that, and so now to update the history, I can do history equals moved node history. And I'm going to put that like there. That should be an adjust. Let's double check that. Okay, still works. And let's give this function its type. And boom. So this is, I did that with the Haskell language server module mode. Okay, so we have an element ID, an app state, and app state. And currently we aren't using this relative position. Okay, so let's double check that we're getting that added to the history. So if I just left click, it says added node. If I click and release and click again, it says move node. If I click and release, I've moved it twice and 3 times. Great. Okay, so now we know what has changed, but we need more information. So in order to undo adding a node, that means removing a node, and so we need to know which node to remove. And so we need to add the node ID into the history. And when we move a node, we also need to know which node was moved and where it was moved from. So let's first do the add a node. So let's add a to-do Okay, so I've added that to-dos, and now for added node, let's add which node, and the types for that is element ID. Which is just a new type of an int. Okay, and so now we've changed that type, we get this nice error message telling us we need to specify that. And so this element ID is the new key. Let's call this the node ID. And so we can just put that in here. And I need to give that the right type. Great. So now let's try running it again. Now I can see that we've added node 1, and now we've added node 2, added node 3, etc. Great. Okay, so now let's so now I could either add the data for moved node, or I could go ahead and write the code to undo to remove a node. So yeah, let's start on undo. So I'm going to do that as a as an action here. So I want to do ControlZ for undo. Eventually there'll be, a GUI and you can press an undo button. But for now, I just want to make that a keyboard shortcut. Okay. So currently I'm just using the mouse. So I believe I'll need to add some sort of GTK or GDK callback for a keyboard event. So I have a button press event, and now I need some sort of keyboard event. So let's see how to do that. Keyboard shortcuts. Keyboard input. Okay, how do I handle keyboard events in GTK3? Okay, so first I need to enable the GDK KeyPressMask. So I believe I currently have a mask for the background area. So let's add a mask for KeyPressMask. Okay, let's say event mask. KeyPressMask. Okay, that is a thing. And I have a callback for KeyPress event. Okay, so there's a callback. Let's make a function for that. And this is just going to be an IO bool. Pure and something is not like that. No instance for maybe that keypress is not. Well, I need to give this a event something. That, no. No instance for that's strange. I don't. So it says no instance for gObject inputs app state event button. Something is strange here. Oh. There we go. Okay. So I'm not sure if that's actually working here. So I'm guessing this might need to be called on the window, actually. key press event. Yeah, that's saying window. Window. And let's add this mask to the window actually. Okay, let's see if that works. And it works. Okay, so the next step is to figure out what this is actually being called with. So I should be able to look at this key press event. Event. I'm not quite sure what that is. Oh, I have not enabled that yet. on widget key press event. Okay, so that's the type we want. Yeah, so that's why I don't like these magic hash things, because I don't know what's actually happening. No. Yeah, let's also get rid of that here. Okay, great. So now that's cleared up. And so now I can see here that this is a widget key press event callback. So I can see the type and see that it takes a gdk.event key. Okay, so I'm going to take a little break now, and I'll be back in about 5 minutes. Okay. Okay, and I'm back. Hmm. Okay. Okay, so we're doing key press events. So let's look at this gdk.event key. Um, oh, okay, that's nice. It tells me where that's defined. Event key KeyVal. Okay, so it looks like what I want is the KeyVal. So I want get event key KeyVal. And so this KeyVal is a word 32. Let's print that out. So I assume that's okay. I need to convert that into a key. Get event key string. That might be what I want. Okay. So ControlZ is /sub. apparently. Let me make sure I use a... Oh. I did ControlZ in the terminal, which is not what I intended. And now glance. Oh. Okay. Okay. Case. Okay, so I'm now just double checking that I can recognize that key. And Control-Z pressed. Great. So I have no idea if this is the proper way of doing this. So I'll just make a to-do or a comment. Let me just double check what. So we have strings, we have event key type. Event type. Interesting. So it looks like we have the string. Modifier type. Okay. So if I'm going to do Control-Z, it looks like I might want to check that the Control key is pressed with the modifier, this thing. Okay. Oh, okay, so there might be GDK constants for this. Key map. So key. Oh, lots of things here. Key. Huh. Interesting. So I have KeyZ. Question is that the same? Let's also get the key. So I wonder if there's some code for, so you can do key something or other underscore. Oh. Key underscore something or other. Okay, so I'll make a note of that, but since I've got something basic working now, I can figure that out later. Okay, so I've got a key press. So now the way I've been doing this has been to update the input and create an event, or add an event, an input event. So let's go to our input events and add an undo event. I think that's pretty self-explanatory. And so now for this key press, I need the key event, and I also need the inputs. Okay, so for these, it's only one action here. Yeah, let's make a separate function for that. So I'll call this So I'm just looking at what I did here for the right-click action. So I'm going to modify IO ref, inputs ref, and I'm going to do this. I already made a function to add things to the events. Add event. And that's just undo. Let's double check that. Okay, so there's now a whole bunch of stuff. Yeah, too much stuff in the history. Okay, great. So the reason this failed here says non-exhaustive patterns in case. So there's no fallback here. So normally the Haskell compiler will complain. Oh yeah. So here it gives me a warning, pattern matches are non-exhaustive. And so that is expected. And let's just do nothing right now. And now we see that warning's gone away. And I can do ControlZ, and it says adding undo input action. And nothing's actually happening since we haven't implemented it yet. Great. Okay, so now we can implement this. So let's do undo. And for that, I should just need the old state. So I have click on node, then add node, but this order is flipped. So I'm going to make sure that order matches the type, which is click, then add, then undo. So let's move this up. So undefined just means undefined can have any type. So if you actually try and evaluate undefined, you'll get a warning. But it's useful for when you're writing code, because then you can not get a compile. It'll still compile, and you won't get that warning there, that error there. Okay, so undo. So we need to get the history. So the first thing is I want to get the first part of this history. So if there's nothing, then we do nothing. And if we have a history event, then I do want to do something. Okay. So now this will depend on which history event it is. So if it's a moved node, as that's currently a to-do, we don't know how to undo a moved node. And if it's a added node, then we will want to remove a node. Okay, so let's make a function to remove a node. And, oh, that took a while. Instead of using undefined, you can also just use an underscore in many places. Okay, so now how do I remove a node? So the first thing I want to do is I want to get the elements out here. And this is an int map. And so let's look that up. Okay, so there's a int map.delete. Takes a key, an int map, and returns a new int map. So let's try that. So this node ID is a new type, so I need to convert it to an int. Okay. So supposedly that compiles. No, there's a parse error. This needs to be app state. Ah, that's an underscore there. And let's just see if what happens. So I add a node and then I do ControlZ and it disappears. And so it's only removing one node. And the reason this is happening is that we aren't removing that history event. And so it's trying to remove a node that's no longer there. Okay, so let's add some type signatures. So this should not go, let's see. So let's just yeah, so what I could do is I could remove that from the history inside of remove node, but you know, there's going to be multiple functions here and they'd all have to do that, so it would be better to do that to remove the history event in undo. So this does mean like multiple changes to the state, but hopefully the compiler figures out how to do that efficiently. So let's call this undo applied. State with undo applied. And the new state equals, and we want to modify the history. So let's see, does tail work with an empty list? Okay, so I don't want to use tail here. So let's I'm going to move this undid state update inside of this case. And so now I can apply the update here. Okay. Undone state. Maybe I'll call that the undone state. Okay. So now I add a whole bunch of nodes, and now I can undo them. Cool. So now this is going to break if I add a node and then move it, because it doesn't know. Oh, I guess it does work because we're removing. It doesn't know how to undo a move, but it still removes that from the history. So I can do 1 move, 2 moves, 3 moves, 4 moves, and then I should take 1, 2, 3, 4. So that's undoing the moves, and then it starts deleting. Okay, so that seems to be working quite well. Implement undo move node. Okay, so I think that's enough code for today. So now I'm going to wrap up and commit this. So let's see what all has changed. Let's see if I can make the font size bigger. Okay, so what we did was we added this history. We added a type for the history event. Let's add a comment here saying explaining what that's used for. We updated the empty app state so that the initial history is empty. Added a function for when we click on a node that we extracted out, and we updated the history there. And we also update the history when we add a node. That's here. Okay, and then we also added the undo action and the remove node function, which deletes the node. And we have the to-do for implementing move node. And so when we do that, then we'll need to add the at least the position of where the node was moved from to this data type. Okay, so we extracted out the click on node logic. And we did implement undo, so let's remove that. And we don't need to print out the history. There was a new line there. I don't know why this stop is showing up. That really is the same as far as I can tell. Okay, so we added a KeyPress event, which checks whether we've hit ControlZ. And if we have, then it adds a undo input action. And in order to get KeyPress events, I added this event KeyPressMask to the window and added a onWidget KeyPress event for the window. So that callback is called. Okay, that looks good. Let's save that code. And now we need to revert the buffer in Emacs. So now before we commit, let's see if there are any warnings. And I also like to run hlint, which runs a linter on the code. Oops. Okay, so that looks good. Now let's commit. And now I want to mention the issue number in the commit message. And so we've, this is partially implemented, not fully implemented yet. Say, implement, okay. This is issue 12. Now let's push that. So I probably don't need to print all that stuff out. So I'll just make a to-do in the code to remove that. And I also don't need that printout either. Let's just say undo. Right, so I don't think I'll commit that little change next time. Let's check that I got pushed to the GitHub. Okay, that looks good. And it looks like it does have a link to this, and it shows up here, so that's working. I guess you just put number 12. That works. Okay, so I think that'll wrap things up for today. Thank you for watching, and yeah, if you have any suggestions, comments, anything else you want to talk about, just leave a comment on the live stream.